Go ahead.
All right, I'm Jordan of Group 5, and I'm here to talk about the history of solid-state drives. In 1978, the first solid-state drives came out, and this was during the era of the vacuum tubes. In 1999, the SSD drives became computer-oriented. They were also used in servers.
We can edit out all this, like.
Am I doing it all right?
Yeah, you're fine. Just keep going.
Fuck. All right. In 2002, they were used in games and PDAs. In 2005, they got up to be 1 gigabyte and were used in camera chips. Nowadays, SSD cards are used in cell phones, GPS units, and personal computers.
Well, I'm going to talk about the applications for the solid-state drive. The first one they have is cameras. You can take pictures and video and it'll record onto the solid-state drive. The second one is a voice recorder, so you can actually record your voice right onto the solid-state. And the third one is a laptop. A lot of the new MacBook computers have a solid-state drive instead of a hard drive, which has a less fail rate. The MP3 players you can use to store your songs and pictures. And then cell phone, you can store your music on that as well.
Hi, I'm Joe and I'm discussing how SSD works. It's a data storage device that uses solid state memory to store persistent data. Now what I'm going to do is discuss how the inside of an SSD card works. The inside operates on electronic circuitry, is built out of semiconductors. Semiconductors are made out of silicon. Now, silicon is the heart of any electronic device. Pure silicon is an insulator. It's not a good conductor of electricity. But a process called doping can make silicon a good conductor. Doping, you mix a small impurity into a silicone crystal. Two impurities are N-type and P-type. They're not good by themselves. You can't just have N-type and you just can't have P-type. They're not good by themselves. But together they are very reactive and they can produce a good electrical current which helps store data in an SSD card. Now, a good example of doping is the common battery. Now, in a battery, you have two sides of a battery. Now, one's the N-type and one's the P-type. They're the two impurities that I talked about. Now, one is a negative electron and one is a positive. Now what happens is when the P-type, when the battery's flipped around and the positive is with the negative and the negative is with the positive, you got a perfect example of a diode. And a diode is the most common form of a semiconductor, and this is the most simplest form that can be explained of how a semiconductor works in an SSD card. It's a bunch of N-type and P-types together that are producing an electronic flow and current that makes it operate quick with speed, and memory can be transferred very easily and quickly. And that's how the inside of an SSD card works.
Alright, I'm Brandon.
And I'm John.
In Group 5, we're going to do pros and cons of SSD.
I'll be explaining pros.
I'll be explaining cons. So tell me, what are the pros of this?
Well, one of the things is SSDs are 2 times as fast as HDDs, hard drive disks.
But how expensive are they?
Well, they are a little bit more expensive.
So I've read that the price per gigabyte is a lot higher for a solid state than it is for a regular hard drive.
You do got me there. But they are decreasing in price, approximately 50% a year.
Really?
Yes.
I also heard they have a lot of problems. I heard that they only have a limited amount of times they can write to the actual solid state drive.
Well, I guess. But still, come on. You're going to be the coolest kid on the block if you got an SSD.
I mean, what's the difference between SSD and hard drive that would make me get a solid state drive?
They're so much faster. Like I said, 2 times as fast. And in the future, they're going to be part of the no moving parts computer.
Really?
Yes.
Well, what about the 10 to 20% failure rate of solid state drives?
I mean, it's a risk anybody's willing to take for the coolest piece of hardware. Plus, they're not affected by humidity or any debris that they come in contact with, and they're super durable.
What about the performance? It's slow when handling multiple operations, whereas a regular hard drive handles operations pretty quick.
Yeah, but still, they're the most energy efficient hard drive disk, or SSD, that we have today.
Okay. What about fragmented files? Heard that when you defrag a solid state, you actually slow it down over time.
Yeah, that's exactly what happens. The fragmented files slow down because they're writing over and causing that write problem that you were talking about earlier.
Alright, well, I guess that's it. But I would still go with a solid state if I had to choose.
Alright.